again so that you can follow and do it yourself. Who wants to see the stack demo again?
So what?
Fueling out a stack. And you've seen that, okay?
No, we want to do it.
You want to do it? Okay. So, please pull up your Pharo image. Open the workspace. And signal some exception like this. Then do a right click on any of the entries in the debugger. You'll see at the bottom there's a fuel out stack entry. If you click that, you'll get a file named accordingly called debugger something. Now if you close this stack again and pretend this is a fresh image, you can simply drag and drop the file into the image and voila, get the external stack. And that's exactly what Camilo showed, but with test failures on Jenkins. Yes?
So why in this case the stack is so large and then when I file it from Jenkins it's just often just a couple of, why is it here normally for Jenkins?
Well, because it's not only a textual representation, but if you look at the stack, you can go right to the bottom, pick anything, and let's say inspect this context, explore this, and what you see is that you get all the objects that were there. So you have the morphs and everything, and all that stuff was serialized. So in Jenkins, when it's run in headless, obviously you don't get the morphs, and there's probably some more strict stuff. I don't know, they only use the kernel. And
I think it also cuts the stack.
Yeah. Okay, so
Is there any reason for that cutting?
Because
it's serializing the image.
I mean, you're not interested in debugging the startup code of the image, just your own code.
but generally this is really cool because there are a lot of cases when you, especially in the textual representation, that there's just information missing that you need. Okay, so what I'm going to show you now is how to fuel out something manually, which is very easy, and what I'm going to show you is how to serialize a method context, because method contexts are kind of special, and the ability to serialize them is only added in 1.9. So what do? We get a FL serializer, and that object, the class, knows the message serialize to file name. And we want to serialize as a method context. Now, because this is a bit of a special object, we have to grab an this next part, you won't be able to take pass in, which is, I want to show a use case which I encountered at work. And for that, I'm going to have to start a virtual box. Inside this virtual box is a goods database, or a goods database server actually. For those of you who don't know goods, goods is a object database which is actually a pretty cool tool, but we put so much data into that database that it made everything really slow, and we had to find another solution. So we had to figure out a way to get the data out of the database again. And if you look at this browser here, you'll see an object called KK Object Proxy. In goods, every object is proxied. So when you request a reference, you actually send a message to the proxy. The proxy gets a does not understand, and then via this XXX object message retrieves the real object from the database and performs the sent message on that object. Because the object proxy is inherited from proto-object and not object, there's also the problem that if you send class to the proxy, you will get the class of the real object. So at the point where you want to extract all the objects, you really don't want anything to do with the proxies, but they interfere the whole time because they intersect all the messages.
Just the truth. We removed the file that test was outcoded in Pharo.
So what class?
Test now is not outcoded anymore in bytecode.
Ah, okay. Yeah, so just to clarify, I'm talking about Squeak. Yeah. And we were moving to Pharo. Yeah. Okay. So how do we get rid of the proxy and nicely get all the data out of the database? Then I stumbled across Fuel, and Fuel allows me to stop class to override this nice message implemented on objects, which looks like this. Generally, the method looks at the object and then sends a specific message. This is just for optimization. Now, if you want something special to happen, you can override that method. It takes a macro as an argument, and what we do here is visit a substitution of the current object and replace it with the real object. So what Fuel does is it traverses the entire graph that you want to serialize, and whenever it encounters a KK object proxy, it will replace that with start with, sorry, I need a Pharo image for that. Okay, so file system, disk, working directory. This is the directory that the image lives in. And now the file name will be, I don't know, say analyzer.fuel. Then we open the write stream on that file. And then we have that stream to write on. So as I mentioned before, I didn't mention it actually, so Fuel uses, because of the pickle format, it uses a two-step process for serialization. First step is analysis, where it traverses the graph and collects all the objects and groups them in pickle jars. And the second step is the serialization. So if you want to change something for the serialization, we have to sort of interfere during the analysis step. So we'll create our custom analyzer for that, FL analyzer. Tanker is an experimental package loader which uses fuel. And the goal of this package loader are to be as fast as possible. And one way to do this is to use minimum compilation. In fact, now it only compiles traits, I think, and there was some other special object that had to be compiled. But otherwise, you don't install source code, so you simply put the bytecodes back in, and you don't have to compile anything. And also, we want to write the changes file only once. Of course, we want to remove the changes file eventually, but up to that point, we collect all of the changes and do only one write, thus limiting the I/O operation. Again, nothing yes and my current version is 1.1. Now, please keep in mind this is really experimental stuff, and the demo I hacked together is really a hack, because what I'm going to show is how to load the entire seaside with Tanker in 30 seconds, which is a really cool demo. But since Seaside can't actually yet be loaded into Pharo, I had to hack Seaside. And that's why you'll find a folder in the zip archive you downloaded. And in that folder are all the Tanker packages that we need to load Seaside. So I'll just show you what I did to actually export Seaside in this way. So what I have to say is that Tanker is really fast. So I did time measurements, and with Metacello it takes me 6 minutes to load Seaside. With Tanker it takes me 32 seconds. But Tanker does not pull anything over the network, and Tanker has no notion whatsoever of load order or dependencies. The only thing it does is make sure that superclasses are loaded before the subclasses. So we had to have a way to sort of put that information back in. And what we have here is a simple script which steals the knowledge of dependencies from Metacello and then exports a script which is also in that folder, in the zip, which is named Seaside Load. And the load order is actually simply an array of the different packages, and really the only Tanker code in here is this statement here. So now I'll open the Seaside import image that you also have. And in this image you'll find that there are no Seaside references. Just to prove that I'm not fooling you. There is no WA anything, and there is no Greece thing. So now, since in where am I? Okay. Now you take this ST script, just drop it on the image, file it in, and now it will take 30 seconds, in which I don't know what to talk about. So does anyone have any questions?
You said it's experimental.
Yeah. you want to see code examples, or should I finish? Who wants to see code examples? Like how to manually export, import tank, but it's basically the same as in Fuel because it's a Fuel.
I have a question. Is it available for VisualWorks as well, or is that speed Pharo only?
Well, there's no reason why it shouldn't work because it uses Fuel. And as you saw, Fuel was ported to Squeak, or made compatible with Squeak, but you will definitely have to put in some work to get it running on VisualWorks. I have no clue how VisualWorks actually.
Fuel was originally developed in Squeak or Pharo.
Fuel is Pharo-centric,
Okay.
but since Squeak is very similar and a lot of people use both platforms, we chose to support as much as possible. Right. So, right. And since Fuel is already mature, pretty much, we want to just maintain it, and we have a few ideas for enhancements. One is improve performance where possible. It's already very fast, of course, because in the analysis phase, it's not as fast as on the serializers, but materialization is much faster. Then there's some old code left that we have to remove. And then I think Tanker is really cool, but someone will probably have to find an application for it. So, as I said before, maybe we can use it as I don't know, back-end submitter solo to do the loading or to replace something, whatever, and refactory cleanup. These are the web pages to Tanker and